fx equal to 0 for all irrational x and fx is equal to 1 for all rational x. Prove that f is not Riemann integral on closed interval ab for any a strictly less than b. First of all, we have to define a partition. Let's say it is x0, x1, x2 up to xn. Let this be a partition of closed interval ab. Now because it is given that f of x should be 0 for all irrational x. Now when we define the interval xi minus 1 xi, we know that for all the real numbers there are infinitely many rationals and irrational existing in that interval. What is mi? It is the supremum value of f of x on this closed interval xi minus 1 xi. Alright, now because every interval is having infinitely many rationals and irrationals, right? So here it is given that f of x, take f of x to be 0 for irrational x and f of x equal to 1 for all rational x. Because we are taking the value for the capital Mi, that is the supremum of fx, let's take that to be equal to this 1 for all rationals x. So I have to write that as this segment contains rationals. It is also containing irrational numbers, but for rational numbers I am taking the supremum value to be 1. And small mi, this is the infimum of fx on such interval. And this is equal to, now what is the infimum value? We have to take that to be 0, as because 0 is for the irrational numbers, as this segment is also containing the irrational numbers. So I have to mention here irrational numbers, right? It is not given that f is not Riemann integral on R alpha. So here alpha is not present, only R is present. That means this example is talking about not Riemann Stieltjes integral but only for Riemann integration. So here I have to use UPF only here, no alpha, right? So just take this example simply for the Riemann integration. Then UPF minus LPF is equal to summation I going from 1 to n. Now what is UPF? It is capital Mi delta xi. And what is LPF? It is summation I going from 1 to n small mi delta xi, right? Now this summation, let's put the value over here. Summation I going from 1 to n. What is capital Mi? It is 1. And then write delta xi minus summation I going from 1 to n small mi is 0 over here. And this is delta xi. This is equal to, okay, when you sum up all these delta xi, you will get b minus a. And of course this is 0. So this is equal to b minus a. Now is this number is less than anything? What do you say? Less than? No, but it is of course greater than b minus a by 2. There is existing b minus a by 2 which is less than this number, which means this is not Riemann integral. So because p is defined to be a partition, p was arbitrary, so UPF minus LPF is greater than b minus a by 2 for every partition p of closed interval ab. Hence f is not Riemann integral on this closed interval for a less than b. Here f is bounded but not Riemann integral.